We are currently living in strange times, and I hope that all of you are staying safe and keeping well. A big thank you goes to World Scientific for inviting us to give this seminar, and especially Sue, who is our host this evening. We are very glad that so many people signed up, which shows that there is a strong interest in Chemistry Olympiad. As giving an online seminar is uncharted territory for both Dr. Zhang and I hope that you can bear with us if we face any technical difficulties during this seminar. We will first start by giving a brief introduction about ourselves, followed by an introduction to Chemistry Olympiad. Then we will try to motivate you to take on Chemistry Olympiad and post some key questions to get you thinking. This presentation will last around 40 minutes to 50 minutes, followed by a question and answer session. The whole session should end by 9:30. So I will start with introductions. As you might already be aware, Dr. Zhang and I are the authors for this book, Theory and Problem for Chemistry Olympiad, which is published by World Scientific. I am Zhihan, and I participated in the International Chemistry Olympiad competition in 2016, held in Georgia. After the competition, I trained students for the International Chemistry Olympiad Singapore team for 3 years. Right now, I'm an undergraduate chemistry student at St. Catherine's College in Cambridge University. My main area of interest in chemistry is organic synthesis, starting with how to build molecules through catalysis and investigating the mechanisms of these reactions. Then applying these organic reactions to the synthesis of useful compounds, such as organic materials. I will not go into detail regarding myself, but I just want to say that participating in Chemistry Olympiad has greatly benefited me by increasing my exposure to all the different areas of chemistry. And Chemistry Olympiad has given me many precious opportunities. Thus, I'm hoping to convince you to take up Chemistry Olympiad through this seminar. Now I'll pass on to Dr. Zhang Sheng for the next section.
Thanks, Zhihan. Hi, everyone. I'm the other author for this book. My name is Zhang Sheng. Right, so if you have any questions, please send to my name. Right, I will collate all these questions, and towards the end of the session, I will answer all these questions in our Q&A session. So feel free to send in the questions at any time during our presentation. So as Zhihan has mentioned, we co-authored this book. So a little bit background information about myself. I was, for my entire life, I'm actually working with chemistry, studying chemistry in Peking University in my undergraduate. And then I come to Singapore, study my PhD in chemistry again. After that, I stay in the Department of Chemistry at NUS, being a lecturer, right? So before I graduate, I study chemistry. Now I am teaching chemistry, all right? University chemistry as well as the Olympiad chemistry. So I have been the trainer for Singapore Chemistry Olympiad team since 2010. So it's 10 years already. Over all the years, the Singapore team, which I am leading, has get a very good result. In total, my students have won 16 gold medals and 19 silver medals. That is thanks to the really good education system in Singapore and the good effort of the students and as well as the teaching team, right? My teaching team. Okay. So on the right, I have put on 2 photos to share with you, which both of them are taken during my Olympiad journeys. The one on top, you see myself actually wearing the Olympiad t-shirt. That is the Olympiad t-shirt for the 50th International Chemistry Olympiad. Why I put this? Because that year, is the 50th anniversary of the International Chemistry Olympiad. So on top, you see this banner on that building above the door, which says, "Back to where it all began." So this slogan has a meaning because the first International Chemistry Olympiad was held in the country called Czechoslovakia. And of course, this country no longer exists because now this one country split into two, Czech Republic and Slovakia, right? So it's no longer one country, but because it's 50th year's anniversary, these two countries, Czech Republic and Slovakia, these two countries and the chemists from these two countries decide to collaborate and hold this 50th International Chemistry Olympiad again. So kind of a memory of the first International Chemistry Olympiad. This really touched me when I know, oh, these two countries unite again to host the International Chemistry Olympiad, because it shows to me that science has no border, right? We say scientists have border, we belong to each country, but science does not have, right? So basically all the chemists, all the scientists all over the world are actually working together for a better future of human being, right? Like what we see now, all the scientists around the world are actually working together to fight against the COVID-19 and to give us a brighter future. All right. So excuse me. So I hope students, if you become a scientist in the future, please continue that good spirit. Okay, at the bottom is another photo. I believe those who are doing chemistry, excuse me. For those who are doing chemistry, or even those who are not doing chemistry, I hope you can recognize this is a table. This is the periodic table of elements. But this periodic table is unique because each square, each element is actually made up of a cookie. So some people will say, oh, you guys scientists, you guys are nerds. You know, you don't have any interesting thoughts. You don't have interesting things. But actually, this photo showed me that it's actually not true. The organizer of that year actually baked each piece of the cookie and assemble them together to this, what I call cookie table of elements. Quite interesting. And what it's even more interesting to me is that I see this cookie, which you see on this amplified picture there, which the symbol of that element is actually Sg, right? Why that interests me? Because those who are in Singapore, surely you will know that you know, Sg is the short form of Singapore. So for those who overseas, you now know that Sg stands for Singapore. Of course, on the periodic table, the Sg doesn't stand for Singapore. Right? So now play a mini game on who see whether you can find where this element is on the periodic table. It is not a common element that you learn from school. Neither do I. So are you able to identify where it is? Okay, somebody say it is above the ND. Okay, good. So you managed to locate, yes. Okay, somebody agree with him. Okay, so you managed to identify, yes. Zhihan, maybe you need to change a color, yes, right? So that is, Yeah, that is where the Sg element is. It is in the last period, the 7th period. Very good. I see somebody is able to even spell out the full name of this element. Very good. So it is on the 7th period, and as you know, elements on that period are in general radioactive, and it is actually a man-made element. It doesn't occur naturally. It is a man-made element, right? But I'm still very proud that there is an element with a symbol Sg on the periodic table. Although obviously it's by chance, but it's still quite proud. I think not many countries have their symbols on the periodic table. All right, yeah. Next page, please, John. All right, so here you see another photo. This is the photo that you will see both myself and Zhihan, right? I am the second from the left, you see on this photo, and Zhihan is the third from the right. This photo was taken during the International Chemistry Olympiad 2016, right? That is already 5 years ago, 4 years ago, right? How time flies, okay? And it was that year, the Olympia was held in Georgia. And you see these 4 students who forms a team and represent Singapore. This is after the closing ceremony, after awarding the medals. So you see all my students are holding the medals and they are all smiling very happily. 2 gold medals and 2 silver medals. And the others are my team members, the mentors. I'm the head mentor and the other mentors and MOE staff. All right, okay, next slide. So now a little bit on background about ICHO. So first, what is ICHO? ICHO stands for International Chemistry Olympiad. It is one of the few international Olympiads which include chemistry, mathematics, physics, biology, informatics, and a few others, right? So ICHO is a member of this International Olympiad family. ICHO is being held by different countries which take turns to host the competition yearly, right? Every year, usually it is being held in July. As I've mentioned to you, it was started back in 1968 in Prague, Czechoslovakia. So this year is the 52nd year of the ICHO. Back in the first ICHO, there were only 3 participating countries, but over the years, it grows and grows. So now you see that there are a total of 76 participating countries. That is for last year. I believe in the future, the number will still increase. And each country is entitled to send in 4 students to participate in this ICHO. So there are a total of more than 300 participating students from all these countries. Now, medals are awarded. Gold medal, silver medal, and bronze medal, right? In the Olympic Games, you only have 1 gold medal. But here we give a little bit more because we do want to encourage students and encourage countries to participate. So the top 12% of the students will be awarded gold medals, and you can read the other numbers for silver and bronze. So actually it is very, very challenging to get a gold medal because even it's 12%, it's slightly more than 30 gold medals. And there are a few countries who usually will win quite well. For example, China almost always win 4 gold medals. Russia almost always win 4 gold medals. US win 2, some years 3, some years 4 medals, gold medals. And I'm actually quite proud that for all these years which I am leading the team, Singapore always managed to win 2 gold medals and 2 silver medals, which is, if you compare the other countries which can win 2 gold medals, if you compare the other countries who can win 2 or more gold medals, their population are much more than Singapore, right? We Singapore with such a small population and so few students studying chemistry in your JC level, we can win 2 gold medals and 2 silver medals. I'm very proud of you guys, our Singaporean students, right? You guys are really good. Okay, next slide, please. Right, a little bit kind of advertisement. As I've told you, ICHO was held by one country each year. So last year in 2019, it was held in Paris, France. So very beautiful scene. Students not only doing the competition in the exam, but also they make friends with all these chemistry students all over the world. They have sightseeing, they have many activities. So it's really enjoyable trip and competition. Now, things is a little bit different this year. The original plan is the ICHO will be held in Turkey. This year is in the city of Istanbul. I think 8 years ago, it was also in Turkey. I went there. It was in Ankara. So this time, Turkey hosts again, but decide to change to a city, Istanbul. But unfortunately, because of the COVID-19 situation all over the world, there's no way that face-to-face competition can be conducted in Turkey. So the organizing committee has recently decided to change the competition from face-to-face to an online competition. That's unique. That never happens in the entire history of ICHO. So all the parties are still working very hard to find the best solution to hold the competition online. Next year, 2021, hopefully when things is clear, it will be held in Osaka in Japan. The original plan is actually the Japanese government wanted to host the Olympic Games in 2020, and then after that, the ICHO in 2021, but now the Olympic Games is also delayed. So those who go to Japan for ICHO next year, you probably have a chance to see the Olympic Games together with your International Chemistry Olympiad, right? It's a good experience. Okay, next slide, please. Right, a little bit about how the competition is conducted, right? So again, this is the format. What I'm showing you here is the format of the ICHO, right? As you know that science, chemistry is an experiment-based science. So both the theory and the practical are important for chemistry. That's why the ICHO tests students on both the theory and the practical. So there are 2 exams. Practical exam are held first, which there are always 3 tasks. That is 3 experiments for students to do within 5 hours. If you do the 3 experiments one by one, you will not have sufficient time. So you have to plan your experiments. So that requires your soft skill, time management, to conduct certain steps concurrently. so that you will be able to finish the 3 tasks within 5 hours. And after the practical exam, on 1 day rest, and the 3rd day will be a theoretical exam, which is again also 5 hours. There are typical 8 theoretical problems for students to answer, but some years there are 7, some years there are 9, but typical is 8. This is just simply paper and pen type of answer. So theoretical takes 80% and practical takes 40%. So you add the 2 marks together, and then the organizer will rank all the 300 plus students, rank the total marks, and then give the award. There are also individual award to be given to the students who have the best practical results and the students who have the best theoretical results, right? Zhihan actually have won not only a gold medal, but for his year, he has actually won the best practical result, right? If I don't remember wrong, Zhihan, you have actually won 39.3 marks. 39.9. Wow, it's even higher, right? 39.9 out of 40, right? So very, very difficult. Every year there are some students very close to full mark in theory, but it's actually very, very difficult to get a full mark or close to full mark in practical. Zhihan is really good, right? Okay. Yeah, next. Okay, so back to Singapore. So I will introduce a little bit about how Chemistry Olympiad is conducted in Singapore, here in Singapore. All right, so typically Singaporean students will start to learn science and then chemistry in your secondary school. So we have a Singapore Junior Chemistry Olympiad, which is open to secondary 3 and secondary 4 students. And there is a separate competition called Singapore Chemistry Olympiad, SCHO. And Singapore Chemistry Olympiad is open for JC1 students. So these are 2 separate competitions. For Singapore Chemistry Olympiad, we invite all the JCs in Singapore to send in their students for the SCHO competition. Through the SCHO, we will select around 30, 40 best students to continue the following rounds of selection and intensive training. Throughout the years, the training is always conducted at NUS, and that's why I was chairing the Singapore team. So after the intensive training, we will select the student again. Finally, we will select 4 students who will form this Singapore team, and we will go together to overseas to participate in the International Chemistry Olympiad, right? So you will participate in IChO in your J2 year, all right? So on the right, you actually see the performance of Singapore team over the past 31 years. There are 33 gold medals, 51 silver medals, 36 bronze medals. So actually you can see that for the past 10 years, which I am leading the Singapore team, our performance actually get improved. Actually, over the past years, I show you the number of gold and silver, right? 10 plus gold and 10 plus silver, and there's only 1 bronze medal. Everybody won a medal, and there's only 1 student who won a bronze medal, and it's actually not all his fault. That year, the equipment which he used actually broke. Because he didn't use it properly, And sadly that year, that piece of equipment doesn't have a replace. So he didn't manage to finish his practical exam. And that's the reason why he get a bronze medal. Otherwise, he will also get a silver medal at least. All right. Okay, so as you can see here, Singapore team has actually performed quite well considering our small population. So I would like to really encourage you to try your best to participate in the Chemistry Olympiad journey. Whether you will be the last four or not, you will surely learn, understand chemistry much better, and you will learn how to use a pair of chemistry eyes to look at the world, right? And so you are the next star in Chemistry Olympiad. All right, next slide. Yeah, I think it's Zhihan's turn now.
Okay, thank you, Dr. Zhang. I will continue to talk about why do Chemistry Olympiad. I understand that as students, you have a huge variety of activities to choose from. For example, clubs, societies, volunteering work, and many other things to occupy your time with. So why should you consider taking up Chemistry Olympiad as an additional challenge? There are many logical reasons to this, which I write on the screen. Chemistry is useful. I think if there is a silver lining to this whole COVID-19 pandemic, it is that as a society, we are realizing the importance of science. For example, all the drugs and pharmaceuticals currently in use for treatment, whether for COVID-19 or for any disease, these are all molecules that were made by chemists. And I believe it is very important to see the bigger picture and the impact that chemistry has on our daily lives. Chemistry Olympiad is an intellectual challenge. Other than chemistry knowledge, it also provides very good training for your critical thinking and puzzle-solving skills. My Chemistry Olympiad journey was the most rewarding and fulfilling journey. I think that it is very important to be committed to this endeavor over a long time and allow it to help you grow. Just now, Dr. Zhang has already introduced the Chemistry Olympiad competitions in Singapore and the Chemistry Olympiad journey. And I think that this is the same in many different countries as well. So it starts from a junior level competition, moving on to a senior level competition, and finally the international level competition. And now I want to share my personal journey through this international Chemistry Olympiad competitions. I started Chemistry Olympiad in secondary 3. At that time, I wasn't the top student or anything. I had a clear goal in mind that I wanted to participate in the International Chemistry Olympiad. And as Dr. Zhang has mentioned, it is extremely difficult. You have to be the top 4 in Singapore or in your own country to be able to do that. In the Junior Chemistry Olympiad, I scored a silver medal, which is a great result, but that was nowhere near the top 4 in the country. But I didn't want to just give up. So I continued to work and achieved the gold medal at the senior level Singapore Chemistry Olympiad. And then came 2016, the year of the International Chemistry Olympiad. Now, 2016 was also quite a strange year for the International Chemistry Olympiad because we didn't know whether the competition would be able to go ahead. The original host for the Chemistry Olympiad was actually unable to host the Chemistry Olympiad, and the steering committee had to, very last minute, find another country to host the Chemistry Olympiad, which turned out to be Georgia. But this was only confirmed in April that year. So there was, for a very long time, no host country for the Chemistry Olympiad. And all of us have no idea what would happen to the Chemistry Olympiad. So this was a huge blow to everyone aiming for the International Chemistry Olympiad. Some people stopped preparing midway, but I was determined to keep learning, even when there was a chance that the Olympiad was going to be called off. In the end, all the hard work paid off, and I was in the top in Singapore at the International Olympiad. And I started off as a silver medalist in the Junior Olympiad. The reason I share this story is to make a point that the most important thing is to be determined. Many students have a lot on their plate and are sitting on the fence about Chemistry Olympiad. But if you want to do well in the Olympiad, you have to be determined. And how can you be determined? The most important point that I cannot emphasize enough is that you must love chemistry. The passion for the subject is what will keep you determined for the 4 or 5 long years that you will take on this Chemistry Olympiad journey. So if you are doing Chemistry Olympiad, I urge you tonight to take a step back, not to study chemistry, but just to appreciate the beauty of chemistry. And I share with you 3 important things to think about. Firstly, I want you to think about the underlying logic in chemistry. The beauty of chemistry lies in its logic, and I believe that effective reasoning is an essential ability for a chemist. For example, in organic chemistry, there are many different organic reactions, maybe thousands, maybe millions. And all these reactions are governed by simple principles that we can draw these reaction pathways as a series of reaction mechanism arrows. And this shows the logic behind chemistry, that all reactions actually follow the same principles of how electrons flow between molecules. Secondly, I want you to link together the different concepts in chemistry. Chemistry is a heavily interconnected discipline. So although we tend to look at chemistry in 3 different areas or more, so we think of physical chemistry, inorganic chemistry, organic chemistry, rather than memorizing each concept or topic individually, I want you to show an appreciation for how all these different areas of chemistry come together to help us in understanding the world around us. For example, in an organic reaction, you also need the principles from physical chemistry to help us determine what is the rate of this organic reaction. What is the energy of this organic reaction? Is it energetically favorable or not? And that actually tells us whether this reaction will proceed. So all the different areas of chemistry links together to help us develop this full understanding of what is going on around us. Last and most importantly, I want you to be curious. This way, you will fully enjoy studying chemistry, the joy of discovery, the joy of learning, the joy of understanding. As you continue studying chemistry, ask yourself, why? Why is there this phenomenon? And I hope that as you continue studying, you can find these answers in a textbook, in online, but do not stop there. Go beyond, keep thinking, learn further and discover more. As Aristotle said, the more you know that you don't know. Finding answers is an endless journey, and that precisely is the pursuit of science, delving deep into the mysteries of the universe. More concretely, to find out more about the International Chemistry Olympiad, you can check the website and read widely into the different areas of chemistry. Now, I want to debunk some myths about Chemistry Olympiad by showing you a sample of an International Chemistry Olympiad level problem and discussing how we can go about solving this problem. Chemistry Olympiad is by no means unreachable because it actually builds upon your current chemistry knowledge and applies it to solving real-world problems. And just a short note here, all the excerpts in the next few slides are actually taken from the textbook Theory and Problems for Chemistry Olympiad. So this will also give you a good opportunity to find out what is inside the cover of this book. So here, this problem, problem 3 on sulfur chemistry, to the level of the International Chemistry Olympiad. So sulfur is actually the 10th most abundant element in the Milky Way galaxy and the 5th most abundant element on Earth. And sulfur has a very long history, from fire and brimstone in the Bible to pyrite in the Middle Ages to black gunpowder in ancient China. In fact, sulfur is one of the major components in the alchemist reactions. In modern chemistry, 85% of the world's production of sulfur is used to produce sulfuric acid through this contact process. And sulfur finds its applications in a large variety of fields, for example, polymers, pesticides and pharmaceuticals, and probably more. One place that we can find sulfur is in fossil fuels. And fossil fuels, some might contain quite a lot of sulfur, and this has to be removed before we can use these fossil fuels, for example, in cars. This is because sulfur dioxide is a major air pollutant. However, it is not possible to actually remove all of sulfur, and there is actually some residual sulfur in the fuel that we use, causing an environmental hazard and pollution. So as you can see, this Chemistry Olympiad problem is designed to tackle a real-world situation where we are dealing with air pollution caused by sulfur. So the first part of the question asks us to calculate the amount of sulfur dioxide generated by these oil products. And this falls under the topic of energetics. So this is allowing us to use different energies, Born energies, enthalpies to calculate the amount of sulfur dioxide that is generated from fuel. Now, how does this sulfur dioxide actually harm the environment? One way it harms the environment is actually through the oxidation of sulfur dioxide in seawater. And there is an interesting reaction pathway that chemists have proposed for this oxidation, which you see on the third page. Based on this complex reaction pathway, how are we able to determine the rate of this reaction? How fast does sulfur dioxide oxidize in seawater? And this is a question on kinetics. Finally, in the second half of the third page, we look at acid rain. Sulfur dioxide actually dissolves in water and gives an acidic solution. And this comes in the form of acid rain and corrodes our structures and harms the environment. So this is actually a question on equilibria. How does sulfur dioxide dissolve in water? How much does it dissolve? After it dissolves in water, how acidic is the solution and how harmful it is? So as you can see, for this question, you are dealing with concepts that is actually very familiar to you from high school chemistry. Energetics, kinetics, equilibria, these are all physical chemistry topics that we cover in high school. So Chemistry Olympiad is actually asking us to bring these concepts one level higher, to apply it to a real world situation. For example, here, the pollution caused by sulfur, and maybe use a few extra techniques to help us. So here I will share with you one of the extra techniques that this question is trying to teach, and that is called steady state approximation, which is under reaction kinetics. So in the earlier part of the book, in chapter 2.6 on reaction kinetics, there was actually a clear guide given on how to apply steady state approximation to solve rate equations. So in this example, we actually look at an example reaction here and break it down into 4 different steps. And based on these 4 different steps, we show exactly how to apply steady state approximation. So as you can see, step 1, step 2, step 3, step 4, step 5. And following this method, we are able to finally use this approximation to determine the rate of this reaction. Now, I will not go into detail now about how exactly to do this, but when you have time, and if you are interested, please read the book, and hopefully you will learn how to use steady state approximation. Once you have mastered this technique of steady state approximation, you can go back to try this question again. So look at this question and solve this series of different equations using steady state approximation and find the rate. Finally, after you have solved the question, you can check the answers and solutions at the back of the book. While most books tend to only provide a numerical or symbolic answer, which is what you see in the blue boxes that say answer, we decided that we really want students not only to test themselves with these questions, but also to learn through these questions, which is why we provide detailed solutions and explanations on how to solve these questions. So in this case, for 3.4, here we have actually provided the detailed algebra behind how to do steady state approximation. And this gives you yet another example on how to apply steady state approximation. And you can use this as a tool to help you learn further. So now I'll pass on to Dr. Zhang Sheng to finish off by giving you some food for thought.
Yeah, thanks, Zhihan. Something to add on to what Zhihan has mentioned just now. You see there are some questions from our book. Actually, this set of questions, there are a total of 8 questions. This set of questions are original from myself and Zhihan. We set these questions. So these are not the past year ICHO questions, right? These are all brand new questions set by us, but they are of the ICHO standard, right? So because I have so many years of experience in ICHO, I know what exactly the questions should be like, how difficult they should be, how they should test the inter-area knowledge. So we work together to set these questions. So it is actually a good practice for you. After reading our book, study the chemistry, do our questions before you check the answer. Then you should be able to learn a lot how the ICHO questions are like and how shall you do them, right? How shall you solve them? We also provide not only the final answer, but the thinking process, right? The thinking process is very, very important, right? How do you deduce the answer from the question and your known knowledge? Okay, so now I will give you some food for thought. I will just simply ask you, throw to you a number of questions, but I don't provide answers. These questions are either related to the chemistry knowledge that you have learned or you are going to learn, or some of them are related to our everyday life. Okay, so as Zhihan mentioned just now, chemistry is really, really relevant to our life. Chemistry is said to be the central science because chemistry is related to physics, biology. Chemistry is also related to energy, environment, and materials. All right, so chemistry has its application in all branches of science, not to say chemistry itself. Okay, so here is the first set of concepts that's for your food for thought. That is really, really basic and fundamental in chemistry. That is the concepts of acid and base, right? So from your very early year of chemistry, you surely learn, your teacher surely teach you what are acid and what are base, and acid and base can react, give you neutralization. But have you think about them one more step? Because many acid and many bases are ternary compounds, right? You see this term I put on the screen, ternary compound. What does this term mean? Ternary simply means 3 elements. So ternary compounds means any compound that has 3 and only 3 elements. For example, if you see these 3 acids, which I put in the second box, nitric acid, sulfuric acid, and phosphoric acid. All these 3 acids have hydrogen element and oxygen element. And each of them contains a third element, namely nitrogen, sulfur, and phosphorus. So all of them are ternary compounds with hydrogen and oxygen. Now, on the second row, you actually see 2 bases, sodium hydroxide and potassium hydroxide. Again, both of them contains oxygen element and hydrogen element. So the oxygen element and hydrogen element are common in acid and base. So that's actually very interesting because it is then only the third element that makes the difference between acid and base. So the question is, which elements together with hydrogen and oxygen will give you acid and which element will give you base? And are you able to predict if you are given any other third element? Are you able to predict will they give you an acid or a base? And why is that so? All right. And now if you think one more step further, when acid behaves like acid, your teacher surely tells you that acid will dissociate out a hydrogen cation, H plus ion. So when acid behaves like an acid, which bond breaks? There is hydrogen, there is nitrogen, there is oxygen in nitric acid, but which bond breaks in nitric acid when it behaves like an acid? Likewise, which bond breaks when base behaves like a base? And then the next question is, why such bond breaks? Why not the other bonds? Right? So all these are related to the bonding theory, right? Which you will learn from our book. There are a few bonding theories and you will see them in our book. Now, going one step further, how do bonds form? That is related to the structures of atom, right? You know there are nucleus in atom, you know there are electrons in atom, but how do they combine together to form bonds and form all the chemicals on all the substances and then form our entire world? So that is atomic structure, which is again one of the topics you will find in our book, how electrons surround the nucleus, which makes different elements have their different properties. And the last question I put at the bottom are then on the definition of acid and base. Surely your teacher have told you that, you dissolve acid in water, and hydrogen cation will be dissociated. And if you dissolve a base in water, a hydroxide anion will be dissociated. Of course, that is true. But how about if we do not have water? If we don't have water, for example, if we have a pure potassium hydroxide solid, is that solid still a base? Right, so this is related to the broader definition of acid and base. In fact, there are three definitions of acids and bases. One of each of them is broader and broader, having broader and broader definition. Again, you may only learn the narrow definition in your school, but what is that broader definition and why do we propose that and how is that useful in explaining many reactivity of certain substances, right? So these are all questions I throw at you. I won't provide answers here. You either know some of them, but the others you think, right? If you can't find a reason, you learn more about chemistry, then you will be able to find out why is that so. Okay, yep, so that is for this one. Next slide, please. Okay, the second food for thought is about, is actually related to the question you saw just now. It's about the oil, right? So the oil is one of the fossil fuels, the crude oil, but we do not use crude oil directly. We have to process crude oil in the very huge device on the in the chemical engineering industry. Singapore is actually very famous of that. We have many chemical industry on the Jurong Island. For example, we will use a technique called fractional distillation to separate crude oil into various components such as gasoline and diesel and so on. All right, so you have again learned that in the O-level syllabus about fractional distillation. But then my question to you is that what is the principle of fractional distillation? What does it mean by distillation and what does it mean by fractional, right? How powerful it is, or is there any limitations, right? The principle of this separation is actually not as simple as what you see from your O-level textbook. There are bunch of underlying principle behind it, which we call the phase diagram. And again, if you don't know on how the principle works, you can read our book. We explain there how the fractional distillation works. And then how do you control the condition? How do you design the device? Why the tower on the Jurong Island has to be so high for the fractional distillation to occur, right? Then the last question on this page, which I will ask you is then, you know, we have gasoline, we have diesel. Are they a pure substance or a mixture? Right? If they are a mixture, is there any way for us to further separate this mixture into each pure substance component? And is that necessary? Why do we do that, or why we don't do that? All right, so these are all questions which is actually quite related to our everyday life, because you know, either your family own a car or you take the public transport, you always have to rely on this oil products. All right, next please. Now, this third food for thought is also about a car. Now, this time is about the engine of the car. So, you know how the car will run on the road is that we burn fuels inside the engine, and burning of the fuel will actually convert the chemical energy in the fuel to thermal energy, which is heat. And then the engine will convert the heat into mechanical work and then drives the wheel, and your car can go through. But what you probably do not know is that the engine is unable to completely convert the heat to mechanical work. Why is it complete convert heat to mechanical work? I mean, 100% of the heating energy is converted to 100% of the mechanical work. That is obviously ideal because you don't waste any energy, but unfortunately, the engine is unable to do so. What probably shocks you is that the efficiency is actually very low. You read on this slide, actually most car engines are only of 40% efficiency. Actually, indeed, many engines cannot achieve even 40%. They may only achieve even 30% of efficiency. What that means is every time you burn, for example, 3 liters of the gasoline, actually out of which only 1 liter is being used to do the real mechanical work, the other 2 liters of your fuel are actually wasted. You will say, oh, why is that so? Why the efficiency is so low? I waste 2/3 of my energy, right? So actually there is a reason for that, and that is related to what we call thermodynamics in physical chemistry, right? It's not physics, but physical chemistry. There's thermodynamics, which is, there is a set of principles and laws which will explain to you why the efficiency is so low. Now, is there any way to increase the efficiency? Yes, there is. Again, if you read our book, Understand This Law in Thermodynamics, you will say, oh, how can we improve this efficiency? And the third question on this slide is then, how about if we don't use a car engine, right? You know, car engine is so inefficient. Is there any other way which can increase the efficiency? Maybe there is, because nowadays everybody is talking about the electric car, the car driven by electricity. Will that give us a better efficiency? All right. And how do we design that? All right. So again, this is related to the electrochemistry, which is again a sub-branch of physical chemistry. Okay. Next slide, please. Now, this one comes back to the textbook. You see 2 reactions on the right. These are 2 organic chemistry reactions, right? Organic chemistry in Singapore syllabus usually comes quite late. Typically, quite a number of schools only teach you in J1 or J2 years. And so you may or may not have learned this reaction yet. But I do know actually there are some, not that much organic chemistry in O level as well. So probably you also have seen these reactions in your secondary school. So allow me to explain these two reactions a little bit more. The first reaction, you see that on top, the reactant is an alkene. You see a double bond there, right? You see two lines between the two carbons. We didn't write out the C. The kink, the bend point, is just a carbon. So you see a carbon-carbon double bond. This is an alkene. And the reactant is a bromine 2 molecule. So what you see here is the carbon-carbon double bond before the reaction becomes a carbon-carbon single bond after the reaction, and both bromine atoms are added onto the organic molecule. So basically you form two new carbon-bromine bond. And this is what we call an addition reaction. Two molecules combine together to form a third molecule. So at the bottom is then a different reaction. At the bottom is no longer an addition reaction. You can see the reactant molecule is what we call a benzene. There are three carbon-carbon double bond. It's a benzene molecule. There is a blue hydrogen there before the reaction. After the reaction, you see that blue hydrogen is actually being replaced by a red bromine hydrogen, a bromine atom. So the other parts of the molecule are not changed. So this reaction is a substitution reaction because the hydrogen atom is being substituted by the bromine atom, right? So the first reaction is an addition reaction. The second reaction is substitution reaction. Now, my question comes, what makes a difference? The two molecules look so similar. Both of them has only carbon and hydrogen element and nothing else. Both of them have carbon-carbon double bond. The only difference is on top you have one carbon-carbon double bond. At the bottom you have three carbon-carbon double bond, and that's the only difference. And why this minor difference in the structure makes such big difference in the reactivity on addition versus substitution. Now, if you have learned these two reactions, your teacher may have mentioned to you about certain property of the benzene that that is the reason for these two different reactivities. But if you ask further, what is that property? Why that so-called property will make this big difference? And more importantly, if in the future you see any molecule with the carbon-carbon double bond, are you able to decide whether that molecule will undergo addition reaction or substitution reaction? All right, so that is related to the reactivity of organic molecules. Okay, next slide. All right, okay, this is the last one, which is about this famous molecule called hemoglobin. I'm sure you have know this molecule because that is the molecule in our blood which is in charge of transportation of oxygen. Without hemoglobin, we won't get oxygen being delivered to all the cells in our body, and we will die, right? So in fact, it's not only human being, but also many other animals. But interestingly, there are some specific animals which their blood are not red in color. By the way, the red color of our blood is because of the hemoglobin, but there are certain animals which the blood are not red, but blue. In their blood, there is this molecule called hemocyanin, and that for those animals, hemocyanin is carrying the oxygen. So, you may say, hey, on all this, biology, why do you talk about them? Now, here, look at the structure, which I show on the right. This molecule is called heme. That is the core structure of hemoglobin. And in the center of heme, you actually see an iron atom. You see an iron atom in the center of heme, and that iron atom is very important. All right. Also, in the center of hemocyanin, which I didn't show you the structure, but I tell you, in hemocyanin, there are two copper atoms. Right. So you see that they have something in common. They have, both of them have an metal at the center. And actually that metal is a transition metal. And that transition metal plays a really, really critical role in the proper function of hemoglobin and hemocyanin in the delivery of oxygen gas to the cells. And why is that transition metal so important? This is actually related to the inorganic chemistry, which you will find out the exact reason from our book. But then there is another question. You know, we breathe in an oxygen and we breathe out carbon dioxide. So our blood actually carries both oxygen and carbon dioxide. Why we always only emphasize that hemoglobin is carrying oxygen? Is hemoglobin carrying carbon dioxide? Or carbon dioxide doesn't really need anything to be carried. It can just simply dissolve in our blood and being transported. Is that so? And then you will ask, why not oxygen? Will oxygen just simply dissolve in our blood even without hemoglobin and then being delivered to, you know, all the cells? Well, then there is no such problem or any issue about hemoglobin. Is that true? Or is that a must to have hemoglobin to deliver oxygen, right? So these are related to physical chemistry, inorganic chemistry, and biochemistry. Biochemistry are those study of the biological molecules by using chemistry knowledge, right? So all these are branches of chemistry. All right.